Welcome back to more Space Engineers Programming with your host, Pilot Air 42. Today, if you notice, we are in a completely different location. This is one of my many survival worlds. This one I play with a couple friends. And today, we're going to have some more fun with the text panels. You can see right here, we have a component manifest. It is a list of everything we have in all of the in our inventory. It does include Sparky here, my welder, and all the stuff in him, because they changed it a bit ago. I'm not sure exactly when, but you can you can bridge the grid gap as long as they are connected with a connector. So I can actually access all the inventories that are in there. And that's pretty cool. So, if you notice, you have your text panel with actual text on it. And here we have our ingot manifest, which is a list of all of the ingots we have. So how did I do this? Well, one thing that this wonderful ship is missing. Let's go through the computer room. Go through in here. This is not finished. I need a med bay, or a like a medical, an infirmary is what I need to set up so that I have a better place for this. Let's go down here to storage. We have all of our refineries right here. And it'd be real nice to have a list of all of the refineries. If you would just have an ore manifest. I'll rename this guy to ore manifest. And make sure the permissions are set up so that I can get to it. So this guy's all ready to display the public text. So how can we get a sum of all of our unrefined ores? That's what I want to display here, my unrefined ores. Well, we're going to go back. Well, I can't get through here right now. So when I move that, you'll be able to get through there. But until then, I just gotta go around. And believe it or not, this ship started off as the yellow, still needs some coloring work, as the yellow respawn ship. If you notice right here from the front, it looks a little familiar. But been hacking away at it, adding to it, taking stuff away, reshaping it and stuff. So let's go in here in the computer room. So we're going to go from here. We're going to edit it, and we're using as a starting point the debugger. The whole debug code gives us access to the we know that we can do text output. The only thing we have to do to make this suddenly work is change it to the public title that we had chosen. And let's also make sure that I did ore manifest. Okay. So, first things we need, what do we need to do? We need to get all of our inventories for the entire ship, because we may have stuff in cargo containers. We don't need the assembler inventories, but when we do get the cargo inventories, it's just as easy to it's actually a little bit more difficult not to get the assemblers, but to get both the cargo and the refinery. And yeah, so we're just going to get all of our inventories. and then get all our inventory items, because if you remember, that's how the IMyInventory item is the data structure for the actual items that are in the inventory. Then we need to sort of filter into unique and totals. What I mean by that, I spelled inventory wrong. We don't want to list iron ore 17K, iron ore 5K, iron ore 8K. We want all the iron ore combined into one object that we can then display our summary of it. Make sense? Cool. So we don't need this. And since we also want to take this guy, this forces a refresh on the panel, because there is currently, as of this writing, a bug in the text panel. So we're just gonna, we only need to do this once and at the end to refresh the text panel. Okay. Just going to delete that. I will edit that later. So, how should we start? Well, why don't we just start with getting all of our inventories. So we want to get a list of my inventory. Get all inventories. So when we get all of our inventories, we can do that. I'm just gonna shove this guy down here by just calling get all inventories. Get all inventories. What goes in here? Well, we want to get all of the IMyTerminal blocks. They added part of the IMyTerminal block extensions. It's not in the actual class definition, but it's in an extension definition. Sorry, not in the interface definition, but it's in the extension definition. That whether it's a type of block that has normally an inventory or not, you can actually call the function that lets you get the get inventory count, which will be currently 0 through 2. Terminal block. That's a standard list. Reach out to our grid terminal system. Blocks of type. Terminal block. And we want to put that into all inventory owners. And we're actually going to we're going to write a little block sorter. So the block sorter is that's a Boolean function that takes one IMyTerminal block and returns true or false as to whether it should be included in the get blocks of type. Pretty simple. Block sorter. IMyTerminal block. Just call it cur for current. And this is going to be just a super quickie return has inventory. I'm not sure if that function means it has stuff in its inventory, or if it just has an inventory, probably the latter, so that your programmable block will return false. Your assembler will be true, and such, so forth. So that way, we only get the terminal blocks that actually have an inventory associated with them. So what do we do now? So now we need to, from our terminal block list, we need to get the inventory. Oops. Just standard list. We want to indent that. So we will, I'm gonna tighten this up a little bit of OCD going on. We're going to loop through the inventory owners using standard iteration. And then in here, we are to shorten stuff up. Actually, this should be, instead of allocating the space for a new variable in each iteration, we're going to block equals all inventory owners at C. And then, because we can have more than one inventory, because assemblers have both the ingots and the components, we want to loop through the inventories. So we're going to, for int inventory number equals 0, inventory number is less than current block gets inventory count. And within our for loop, we're just going to add to the all inventory, we're going to add the current owner dot get inventory at the current inventory number. So that right there, will this actually compile? Current owner 32. Oh, sorry. Current block. I was thinking it was an inventory owner, which, yeah. But our current block, get the inventory count. I'm going to iterate through it. I'm going to add on to it. And then, don't forget to return the all inventory list that we made. So now, if we check code, okay, so now we have all of our inventories. But now we actually really need all of our inventory items. And we will be doing stuff on that. Item. Okay. So we're going to all items equals get all inventory item. We're going to define a function, get all inventory item, that takes the list of inventories and just pulls out all the items from it. So I'm going to copy that. my item. And copy and paste that. Let's see. Inventories. So what do we do in here? Well, so we have that. We are going to first create the variable that we're going to be returning. We'll call this one all items. Period. And that's going to be a new. It's faster if I copy paste it. Copy, paste. Okay. So we're going to loop through the inventories that we have. For 0 c is less than inventory count c++. And within that loop, we simply we need to add. So we're going to have well, let's see. Inventory at c get items. This returns a list of my inventory item. The thing is, you can't just say add this list to the back of this other list. You have to go into each of the items of the list you're trying to add and simply add them on there. So we're going to do another loop. And we're going to loop through that. But the thing is, it'll be incredibly inefficient if every time we're in this inner loop to get all the items and then reference it by I, because we don't know if that makes a copy of it or if it returns a reference to it or what. So we're going to have a little temporary variable. And again, we're declaring it one level. Actually, we're going to declare it not here. We're going to declare it out here so that it only gets allocated once. And then I'm just going to call this guy temp. List by my. So that we only allocate it once and we can reuse it as we see fit. So we're actually going to define it as temp equals that. So there we go there. Now, for each of the inventory items within our list, we do all items dot add, and then just temp at I. And there you go. So that will, this adds to here each of the items that's in here, which we define by that guy right there, is we're looping through our input inventories. So now we have a way to do this correctly. So now we have all of our inventory items. Now we want to aggregate, is that the right word? I don't know. We want to get the unique items we want to total up all of the totals for all the item types, and we also only want the item types that are OR, and not, excuse me, I keep hiccuping a little bit, and not the item types that are components, weapons, ingots. I think that's all. I think those are all the options. Anyway, we don't want those. So, first things first, how are we going to store them? Well, the best, I think, the best way is to create a list of containing an object that only has the information in it that we need. So what information do we need? We're going to define a structure. So, and you do need it to say public. Otherwise, it just errors out saying that it can't get to it. Yeah. So if you remember from my timed delays, I believe it was called timed delays, you can't put an object in the Space Engineer's Objective-C. You can't put a full-blown custom class type in a list. It just doesn't support it. They've hacked up the language or whatnot. So we have to use a structure, which, incidentally enough, in C# you can do pretty much almost everything that you can do in an object you can do to a structure. So we're going to do our struct. We're going to make sure this public string. We're going to work with the ID, which is what we need to make sure. That's what we're going to. That's the key that we're going to use to make sure that we're unique. Public string, the display name, which is what we're going to use to show the OR's name that's going to be output to the text, and we want the amount. So, but since we do have a structure, the one thing we can't do is change any of the structure's values after we've set them in the definition. So, in order to get that total, we need to actually, we're going to do a function that returns a new item info that keeps the ID, keeps the display name, but alters the amount. So amount plus the new amount. So this is just a simple one line. Well, it is one line, but I've, for clarity's sake, brought it over multiple lines. So we call, we have an item info object, and we do a dot add, and it will return a new item info object that is the same as the initial, but with this number added onto our amount. If you notice up here, I also did comparable, because we want to be able to alphabetize this list. And we can do if the item type of the list inherits the interface, implements the interface comparable, you can do a dot sort on it, and it will sort the list. No, compare to. We have the object 2. So and this is the method that it calls to do all the sorting. Is that really as far as we go? Yep. Okay. And all we're going to do is compare the display names. And we're going to just pass it off to the strings.compareTo, which gives us a nice alphabetical thingy. What are those for? This for because the compareTo method doesn't take the item info, it takes an object. So we need to cast it. If it does an error, then somehow we've managed to, at least in how we're going to be using this, we've somehow managed to put something that's not an item info in a list that's supposed to be for an item info. So we don't need to worry about handling any of these errors if this cast doesn't work correctly. Oh, I spelled this wrong. Way back here. Yeah. 109. Oh, I didn't complete my... So that'll define our structure. That's our struct so that we can put item infos in a list. 946 semicolon. 4, 5, 6. Make sure we, yep. Sorry, I forgot to finish the for loop. So now we want to loop through. So we will do our standard for int c equals 0, c is less than. We are looping through the all inventory items. In our count, c++. And what do we do here? We want to first things first, we want to make sure that we're only including the type that we want. And I'm going to define a current item too. It's an item. I'm just going to call it cur. YT@C. So now we have our current item that we're on in our loop. Okay, where are we? Yeah, so we want to make sure that the type of item that it is going to be, in this case, an OR. You can also, you can do it for all the different item types. So we're going to use the as, and we have to fully qualify this, or I believe we can stick a usings up at the top. But the content property is a object builder physical item, which can be one of many different things. Builders.myObjectBuilder. In this case, we want to see if we can correctly get it as the myObjectBuilder score ingot. It's going to yell at me. Okay. And if we can't, then we just want to skip, because we're not the right type. So now we know that current is the correct type. So we want to, now we need to see if we have duplicates of it. So we want to get an index that's the index of the item, the current item within our list items. So we're going to copy that definition. So we're going to return an integer index of item. So the I'll still call that cur. So we look in our inventory item. We look at the current one. In our list of no, it's not an inventory item. Excuse me. This is the what are you? Item info. And did I send it to the correct? Item info should be items. Yeah, it looks right. Sorry. Sorry about that. Yes, items. So we have the list of the item info. And let's see. We want to loop through the items. We do our standards, C is less than items dot count, C++. And each time we loop, we want to check to see if items at our current spot, and we want to look at the ID, see if it equals the, oops, the content and subtype ID as a string. You don't, yeah. So this is what we're going to be using to assign to the ID. So we're going to check to see if it's equal, and if it is, then we're going to return the index that we're at. If we get all the way out of our for loop, we haven't found it. So we need to return some sort of flag. And since an index can only be 0 and higher, -1 is a good flag for that. So where are we? We just found out our index. So if it's not found, we need to do something different as to whether we already have an entry for that item type as compared to if we don't. So if the index is -1, we need to add a new one. Otherwise, we're going to be incrementing it. So adding a new one. How do we do this? I'm going to do items.add. And we're going to do a new item info, which we are giving it the following values. ID is going to be current dot content is the subtype ID. String. The display name is actually going to be the same. I have yet to find a spot that will give me a localized string for that object builder. If you find out where I can find that information, please let me know. But until then, I'm just going to use the same same thing as the ID. So that's why when we were up here, it's bulletproof glass and construction, and not bulletproof glass and construction components, because I don't have a way that I can see of getting into the actual name of the correct display name for the block. So where were we? Okay, so we added the display name and the amount is the cur.amount. Now that is well, let's see. Hang on, I need a semicolon. Display, I didn't capitalize that. The myFixedPoint is this is an internal data type for storing numbers. I think that they mostly use it with inventory numbers. They may use it for other stuff. So there is an explicit cast defined. So there we go. So that will add the new one to the list if we don't have one in there. But what if we do? What if we already have it in there? Well, so we need to take the item that's not at C, at the index that we got back. Okay. And we're going to reassign it to be the items at the index we got back. And remember we added this add, and we need to cast to a double the amount that we're going to be adding, which is the current dot amount. So there we go. Now we have a ready to display list after we alphabetize it. Birds are going nuts in the background. Sorry about that. We are ready to display our data. And I'm just gonna and we also want just an empty line after it. And we made sure to reset the debugger, right? Reset the debugger. Okay. In the future, I will have a string out. As soon as we get programmatic access to the private text, I would like to have the change my debugging code to be a generic output code and have both an output and a debug where the output writes to the public text and the debug writes to the private text. And so that way you can, you will still have all of your debugging stuff while you're still outputting even to the same thing. So we're going to add a header, but we don't have programmatic access to the private text. Sorry. So we have the header. And now what do? We need to loop through. So we're going to go back to our good old C. C equals 0, C. So we're going to loop through the items. And here's where we sorted it. That uses the compare to. C++. We need to debug. We want the items at C.amount. Because that's not a string and it's the first item, we need to make sure that we do that to cast it to a string. You can also just put in parentheses string. And then some sort of spacer. That's 5 spaces. And we want items at C dot display name. And that right there, that's all we need. So we're gonna run it. Ooh, 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 lovely. No idea where this happened. See. I will I'll debug this and get back to you once I figure out where my probably typo is. Ah, I figured it out. Alright. The problem was up here right here we reference the debug panel. That's fine as long as that panel is there. If it's not there, it's gonna crash. So we should do if debug panel is equal to null. We're done. So if we never found the output panel, then just quit. The reason we didn't find the output panel, that's the block sorter, debugging code, is because I did this wrong. So that's should be manifest, right? Compiles. Public test or manifest. Okay. So this should run this time. Ta-da! So let's go see. It's really in the way, isn't it? Boop. There we go. Here's a list of our cobalt, gold, iron, magnesium, nickel, platinum, silicon, silver, stone, uranium. Cool beans, right? Actually, I don't know if that uranium's right. 46. Actually, that looks like the ore and not the ingots. Or that looks like the ingots and not the ore. Did I type in the correct thing? Let's find out. Let's find out. Did I type in the correct component type? In our main. Ingot. No, that's not. That should be ore. There we go. Now we should have the ore output like we wanted, and not the ingot. So what do we have? We have, let's see, 52 magnesium, 997 silicon, and 40,000? 40,000 uranium. Does that look about right? Uh, 12 plus 11 is 33, plus 8 and 9. Yeah, that's about right. Let's see, 52 magnesium, 52.5 magnesium. Is that what we had? Yep. Hooray! So now we have a full manifest of our ore. There is a display nuance that I hate, and that is that not all of the numbers are not monospaced. This is not a monospaced font. So number 1 is, well, it's not as, doesn't take up as much horizontal space as, say, the number 2 or 8. And that's why right here we have, well, so we do have some extra space. The uranium is a much higher number than the silicon, which is a much higher number than magnesium. They're a couple orders of they're orders of magnitude off from each other. So the stuff on the right isn't going to line up. And it's good if I swapped the columns so that magnesium, so that the ore is on the left and the amount's on the right. It'll look even worse. Oh my goodness. Because all the strings are the names of the items are completely different lengths, and there's much higher variance in the width of a text character than there is in a number character. So actually, we can do something about this. But first, I need to sit down before I die. So we are going to do some programming from the captain's chair on the bridge. Ooh. Okay. So here's where we're doing, here is where we're doing the output. So essentially what we want to do is have this spacer vary. I'm going to indent that a little bit. We want this the length of this spacer to vary based on how wide the amount string is going to be. We can tell how many digits the amount string is going to be because we can do that with the logarithm base 10, which gives us the number of 10 spots we have. So the number 40,000, there are 4 zeros. So we can calculate the number of 10 spots we have. So we want to have a, oh, I messed up my indentation. Spacer. I'm just going to assign it to that. And we don't want to add, we want to have, say, a constant number of spacers that gets lower. So lower based on if the number gets longer. So instead of putting log base 10 of the item c dot amount, how do I cast that correctly? I cast that. Yeah, it'll be casted correctly. Yeah, because it is a double. Sorry, I was thinking it was still my fixed point. So if we do something like this, if we put a space this number of times, we should have at most 10 spaces, at least 0 spaces. So we are going to do that to make sure we have at least 1 space. Well, at least 4 spaces. I'm going to do int I equals 0. I is less than that. Oops. I is plus. And we're going to add to the spacer a space. So this becomes our variable spacer. Are we good? Now line 60 selected. Line 60 I is less than comma. Let's make sure that it's actually in that line by making this not a single line guy. Comma expected. What did we do? Ah, that was what? Items at the current index. That amount. String spacer equals a space. I'm going to do that. Okay, so it is in fact in that for loop. I is less. Let's okay. Let's do this guy right here. Is it wanting another? Oh! Ta-da! 10. Why is that wrong? Oh, we have to specify math. There we go. Whew. Sorry about that. Yeah. So we have math.log base 10 of that. So I'm going to run it. And let's check out what the output is. So we have the OR manifest panel. What is the public text? It looks a little bit better. It looks a little bit better. I did do that, right? Right? Oh. Oi, what is going on? Where am I? Who am I? Sorry about that. Log of the item amount, that should give us the number of 10 digits. 10 minus it should give us a good offset. Space number. Yep, okay. Yeah. So yeah. Now we have a nice place where the amount of ore we have to refine is output. So let's hook that up to a timer block. This one already has a few on it. So we want the ore manifest. It'll run it, and this will get run once per second, and then it starts itself. And it's already running. So why don't we drop down it? I don't know why I keep going that way. Drop down over to our storage area. We'll watch that. And now we're going to turn our refineries on, because we do have stuff in them, obviously. So, let's see. Yeah! Look at that stuff refined. So, ideally, most of the time, those numbers would be nothing. There'd be nothing in there. It'd just be empty or manifest. But while we have stuff to do, it will do it. So that, I'm having a lot of fun with the text panels. They've really opened up a bunch of things that I've really wanted to do for quite some time. Like the listing of our components, the list of ingots that we have, which, if you notice, that's updating too, as we're refining stuff. Yeah, I love text panels. Once we get access to the private text via programming, it'll be even better. But until then, that is how to do a manifest. I will put a link to that script in the description down below in the workshop. I have been having some trouble with the workshop files downloading, so they might not be uploading properly either. I'm not sure. Anywho, this has been Pilot Error 42. It's been real nice having you, and until next time, see ya!